All right, hello trigonometry pre-cal students. We are doing lesson 7.5, solving trig equations. And we use algebra techniques like solving for x, factoring, we're going to do a little bit later, and using some substitutions. But it's really important that we know our unit circle. So really fast. Here we have 0 radians, and the ordered pair is 1, 0, right on that unit circle point there. And at here we have pi over 2 radians. So where's pi? Pi is 180 degrees, right? So here would be pi divided into 2 parts. So 1 pi over 2, 2 pi over 2, this would be 3 pi over 2, and all the way around would be 2 pi. Our ordered pairs at these quadrantal angles, right here, 0, 1, pi is negative 1, 0, and 3 pi over 2 is 0, negative 1. Now, the next thing I like to do are the 45s, which would be pi divided into 4 equal parts. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. All the way around would be 8 pi over 4. So really important that you see we're taking pi and cutting it into 1, 2, 3, 4 equal wedges, if you will, if I were to actually draw the angle in. There you go. You see 1, 2 wedges, 3, 4. Imagine. The ordered pair on the pi over 4s, all the over 4s, is radical 2 over 2. And that's kind of nice. And in fact, nothing changes except the sign. So all the way around, it's radical 2 over 2 at each of these over 4s. Over here in quadrant 2, the x value is negative. Radical 2 over 2. Here in quadrant 3, they're both negative. And here in quadrant 4, radical 2 over 2 and radical 2 over 2, the y value is negative because going down. All right. So then we have all the over 6s. And I like just doing over 6. But here is pi divided into, look here, these little pi over 6 wedge. So there's 1 pi over 6. This would be 2 pi over 6, which reduces to pi over 3. And that's important to understand. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which reduces, 9 pi over 6, 10 pi over 6, again reduces, and 11 pi over 6. And so if you can just count by pi's over 6, then you're good to go. Now these ordered pairs are also very similar. All they do is sort of swap, trade places back and forth. So here, to get to pi over 6, we see it's going to take a long leg in the x direction. That's radical 3 over 2. And then up a half, up a short leg. To get to pi over 3, it's a short leg, then a long leg. So that's 1/2, then radical 3 over 2. 4 pi over 6, short leg, long leg, but in the negative direction. So negative 1/2 up radical 3 over 2. 5 pi over 6 is a negative long leg and up a short leg. And so if you can remember those things, then you can complete your unit circle, and this is exactly what we need to know to solve trig equations. So finish that up. So here we go. Example 1, solve the equation for all values from of x. So this is angle x in radians from 0 to 2 pi. And I know it's radians because we're talking about 0 and 2 pi radians. So this is solve the equations for all values from 0 to 2 pi. So that's all values on our unit circle. And that's one rotation of our unit circle. You want to make sure that your calculator is in radian mode. So you just press mode and make sure you're in radians. The Casio, you'd go to setup And what we want to do for all of these is essentially, to get started, isolate the trig function. Okay, that is essentially the first thing. So right here, I have 2 times the cosine of x plus radical 2 is equal to 0. I want to isolate the cosine of x. So the first thing I'm going to do is subtract radical 2, just to move it over to the other side. So I have 2 times the cosine of x equals negative radical 2. That is a negative. I don't know if you can see that too well. There we go. That's better. And then, to get rid of the 2, we would just divide by 2. Okay, so this is not the solution, but this is where we look at the unit circle. It's asking the question, where is the cosine value equal to negative radical 2? And where means what angle? What angle has a cosine value of negative radical 2 over 2? So I always draw a little baby unit circle, and I call this circles and dots. Radical 2 over 2 happens at the 45s, at the pi over 4 angles. But this is cosine value. That's the x coordinate of our unit circle ordered pairs. And negative x values happen here in quadrants 2 and 3. That's where that ordered pair is negative radical 2 over 2. I don't care about the y coordinate. I'm just interested in the cosine coordinate, which is that x coordinate. So what angle is this? It's an over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. So that is x equal, the angle is 3 pi over 4. And also right here, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This would be 5 pi over 4. So how do we know if we did it right? If you're in radian mode, once you get to this point, you can always use your calculator to sort of double check. And we're going to do this again later in degree mode, but I want to introduce it now. So once you've isolated your trig function, we're going to put the left-hand side in y1 and the right-hand side in y2. So left-hand side in y1, right-hand side in y2. And you'll notice we want our x-axis only to go from 0 to 2 pi. So I want to change my window because I only want to go from 0 to 2 pi. And let's just count by pi. So negative 4 to 4 on the y-axis is just fine for now. But 0 to 2 pi on the x, because I don't want a whole lot of extra solutions. So there's our cosine curve, right? High, middle, low, middle, high. And here's where it's intersecting negative radical 2 over 2. You can see there's 1, 2 solutions. So what I can do is I can actually trace and type in 3 pi over 4. And hopefully Tinkerbell is going to land right where that intersection is. And she does. Negative 0.707 is radical 2 over 2. I can also type in 5 pi divided by 4, and hopefully Tinkerbell's going to land right here at that next intersection point. And sure enough, she lands right there where it's intersecting. And again, that's where y is negative 0.707, which is radical 2 over 2. Okay. So again, what we're going to do here is isolate the trig function by first subtracting 1. So we have 2 times the sine of x equals negative 1. I can divide by 2. So that gives me sine of x equals negative 1/2. So this is great information. We can use our calculator to help us once we get to this point. And it asks the question, what angle on the unit circle has a sine value of negative 1/2? And it's angles. There's usually more than one. So we're going to look at our unit circle, circles and dots here. The sine value is the y coordinate on my unit circle. So I'm interested in my y values on that unit circle that are negative 1/2. Well, y values are negative right here in quadrant 3 and right here in quadrant 4. So that's that little short leg. What angles are those? Those are pi over 6 angles. See how skinny that slice is? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. This must be 7 pi over 6. That ordered pair has a y coordinate of negative 1/2. And then, let's see, 8 pi over 6, 9 pi over 6, 10 pi over 6. This is 11 pi over 6. That also has that negative 1/2 y coordinate. So our angle solutions are 7 pi over 6 and 11 pi over 6. Two solutions in one rotation of the unit circle. And we could keep counting and have a lot more solutions if we just kept rotating around. But we only want answers between 0 and 2 pi. Let's try some more. Okay, so same idea. We were trying to isolate our trig function. You'll notice our trig function is being squared. So first I'm going to add 1. So that gives me 4 times the cosine squared of x equals 1. And I can go ahead and divide by 4. So I have cosine of x. Now remember, cosine squared of x means cosine of x quantity squared. And that's important to remember. How do I get rid of that power? If you saw x squared equals 1/4, what would you do? You would take a square root of both sides, right? Don't forget the plus or minus. We want to do the same thing. So we're going to take a square root of both sides. Don't forget the plus or minus. That's going to allow the square and the square root to cancel out, leaving the cosine of x is equal to plus or minus the square root of 1 over the square root of 4 is 1/2. So this says what angle has a cosine value of plus or minus 1/2. So I'm going to go to my unit circle. Cosine is the x coordinate. So we want an x distance that's very short, which means it must be these tall stand-up triangles. And it's positive or negative. So right here we have a distance of positive 1/2 for that x coordinate. And over here would be negative 1/2 for that x coordinate. Well, what angles are those? Same down here. That's pi over 3. 1 pi over 3, 2 pi over 3. So pi over 3. 2 pi over 3 would have that negative x distance. 3 pi over 3 gets me to pi. This would be 4 pi over 3. And then last here would be 5 pi over 3. So this one actually had 4 solutions because of the plus or minus. If it was just positive 1/2, then that would be pi over 3 and 5 pi over 3. But since it's negative also, we also have 2 pi over 3 and 4 pi over 3. So 4 possible solutions. And again, if you're unsure, you can check on your calculator. We want to know where the cosine of x equals 1/2, positive 1/2, but also negative 1/2. So I would put both of those, the right-hand side there in y2 and y3, the positive 1/2 and the negative 1/2. I'm going to change my window to just go from like -2 to +2. There we go. And so you can see, look, there's 2 intersections, and here's the other 2 intersection points. And so again, if you trace and do pi over 3, you'll see there's our first intersection point. This would be 2 pi over 3, 4 pi over 3, and 5 pi over 3. So easy to check. Cosecant, interesting. Same idea. Let's isolate our trig function. So I'm going to start by adding 2 to both sides. So that gives me cosecant of x equals +2. I don't have cosecant on my unit circle. So I'm going to use one of our nice little trig identities. Use that reciprocal identity. Cosecant is the same as 1 over sine of x. Well, I can't solve it when sine of x is in the denominator. So we're going to go ahead and just do a reciprocal of both sides. So we're just flipping the fractions so that we get sine of x over 1 equals 1/2. So you could just jump from cosecant equals 2, where sine is 1/2. So if you wanted to do that. All right. So now this is something that we can look to on our unit circle. So again, circles and dots here. Sine, where is sine have a value of 1/2? Remember, sine is the y coordinate. So we want a short y value. So I think it's right here where we have that y value of 1/2. And what angle is that? Yeah, pi over 6, skinny wedge there. And also right here where it has that short y distance. That would be 5 pi over 6. All right, so 2 solutions on that one. And again, this all goes back to the unit circle. If you don't have a unit circle, you might want to print one out. Just search for it in Google or whatever. Google it. You'll see lots and lots of unit circles that you can just print and have as a reference sheet. It's a really good thing to have. It's better if you draw one. It's better if you can do it that way. All right. Solve for all values in the interval from 0 to 3 pi over 2. All, meaning there's quite a lot of these. You'll notice that there's this number inside with x. So that's going to cause, and again, I'm not too thrilled with the notation. I would like that in parentheses. But there you see that in order to get the angle, it's actually got a multiplier next to it. And that's going to cause some issues we need to work through. We can't just solve for the angle like before because of the number in front. But we are going to get there. So same as before, we're going to start by isolating this trig function. So I'm going to start by adding 2. Here we only want solutions in the interval from 0 to 3 pi over 2. Kind of interesting. So we'll check on our calculator. Let's see. So I have then radical 2 times the secant of 4/3 x equals positive 2. And then I'm going to go ahead and divide by radical 2. So I have the secant of 4/3 x equals 2 over radical 2. All right, again, this is a reciprocal function, which doesn't really help me on my unit circle. So I'm going to go ahead and take the reciprocal of both sides. So the reciprocal of secant is cosine. And we're going to take the reciprocal of the right-hand side as well, which would give me radical 2 over 2. Okay, so we just took a reciprocal of both sides. And so now I can ask myself on my unit circle, you'll notice I'm sort of grazing over this stuff with x. So we have to get rid of this cosine function first. So we want to figure out potential answers here. So where do we have a cosine value of radical 2 over 2? That happens at all the 45s, the pi over 4s. Cosine is the x coordinate, so radical 2 over 2, and here, positive radical 2 over 2 for those x coordinates. Remember, it's cosine, sine, alphabetical. All right. So what angle is this? Excuse me. Yeah, it's that one is pi over 4. also here, let's see, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. All right, so we have two potential answers here. And I think what I want to do is actually do, because of this 4/3, it makes it rather interesting. I'm going to go ahead and look on my calculator and see how many answers I should be looking for. So 4 over 3x, cosine of 4/3 x, and then we want radical 2 over 2. Radical 2 over 2. I'm going to delete that guy. Okay. And for these answers, we only want solutions from 0 to 3 pi over 2. So I'm going to change my window and go from 0 to 3 pi over 2. So there's our cosine of 4/3 x, and I can see that there's 1, 2 intersections. Okay, good. So I have two possible answers. These are not the answers. So what we do, we just got rid of this cosine feature, and so what's left over is 4/3 x. So in order to find out what the angle measure actually is, I still have to get rid of the 4/3. And so we can do that by multiplying by the reciprocal. 3/4. 3/4 on both sides. So that we get x finally all by itself. And this becomes 3 pi over 16. And here we get 21 pi over 16. So let's check, and I'm hoping that that's going to be an intersection point. So trace 3 pi over 16. Yay, look at that. And then 21 pi over 16. There we go. So it gives you an idea of how many solutions we need to look for. If I wasn't sure, what I would have kept doing was, we did one rotation of the unit circle, but I could have gone a little bit further. If this was 7 pi over 4, 8 pi over 4, then it was possible that we might have 9 pi over 4 as a potential solution. But we only needed the first two. So sometimes you might have to keep going a little bit further. 3 pi over 16 and 21 pi over 16. All right. Interesting. Let's try one more. Tangent. We haven't really done a tangent function. How do you get tangent on the unit circle? Yeah, so I can say stuff like, going back to my unit circle, the sine of pi over 6 is that y coordinate, 1/2. And the cosine of pi over 6 is that x coordinate, radical 3 over 2. Well, tangent of pi over 6 is quotient identity, the sine of pi over 6 over the cosine of pi over 6, or the y over the x coordinate. So that would be 1/2 divided by root 3 over 2. And so those 2's cancel out. We get 1 over radical 3, which we would then rationalize. But we can get tangent by doing sine over cosine, and that's important to remember. All right, let's look here. Once again, there's stuff with x that we're going to have to get rid of at the end. But before I do that, I just need to get tangent all by itself. So I'm going to divide by 3. So we have tangent of 8 pi x equals negative radical 3 over 3. So right now I'm going to go to my unit circle and think to myself, what angle gets me radical 3 over 3? Well, actually, we just did it. This was 1 over radical 3, and if you rationalize, you'd get radical 3 over 3. By rationalize, I mean multiply top and bottom by radical 3. Now, so those are the pi over 6 angles, That one was positive. Here we want negative radical 3 over 3. That's going to happen right here. Let's check. That ordered pair at 5 pi over 6 is negative radical 3 over 2 and up a half. So tangent at 5 pi over 6 would be sine over cosine. 1/2 over negative radical 3 over 2. The 2's reduce, leaving me with negative 1 over radical 3, which I would then rationalize and get negative radical 3 over 3. That's one solution. Down here, we'd have negative divided by negative. That'd give us a positive result. But right here, at 11 pi over 6, we would also get negative radical 3 over 3. So there's two solutions there. Let's see. 5 pi over 6 and 11 pi over 6. Let's check our calculator before we do anything else. I'm going to go ahead and put this into my calculator just to see how many solutions I'm looking for. All right, so we have tangent of 8 pi x in y1 and negative radical 3 divided by 3 in y2. Oh, oops, look at that crazy graph. We haven't graphed tangent before. I want to change my window so that I'm only going from 0 to 1/4. So this is the tangent curve. It's kind of like a cubic function. There we go. Oh, good. So we do have just two solutions, two intersection points that we're looking for. So that should be good. So now we can say, hey, we got rid of the tangent. We solved for the possible angles, but we still have the 8 pi in front of our x that we need to solve for. So now how do I get x by itself? I'm going to multiply by 1 over 8 pi. It's the same as dividing. I'm going to multiply this one by 1 over 8 pi as well. And so we get x by itself, and this becomes 5 pi over 6 times 8 is 48 pi. So the pi's reduce, and we get 5 over 48. Here we have x equals 11 pi over 48 pi. And the pi's will reduce, and we get 11 over 48. So let's check and make sure we did it right. I'm going to trace 5 over 48. Yay, good. And then 11 over 48. Oh, right there. Perfect. Exactly where we want her. Very cool. Two solutions. Use your calculators. Remember that that is a really helpful tool. Left side in Y1, right side in Y2. And that's a great way to help you figure out if you did it correctly. Folks, that's it for me. Learn that unit circle. If you don't already have it memorized, you should be able to draw it. Have a great day. Let me know if you have any questions.